Hey guys, and welcome back to Blackthorn Prod. In this tutorial, we're going to learn how to create a chat system for our multiplayer games in just 6 simple steps. By the end of this tutorial, you'll have a very simple but solid chat system that you can use in any multiplayer game. So without further ado, let's jump straight into it. So step 1 is of course to create your multiplayer game. In this tutorial, we won't have the time to show you how to make an online game, but check out this video we made, links in the description. They'll show you step by step how to make a simple multiplayer game using Unity and Photon. Let me quickly show you what my game looks like at the moment. So first of all, we have this connect scene that lets us choose a name for a player, and it connects us to the Photon server. Then we enter in the lobby scene, which is the place where players can create and join rooms. So let's say this player creates a room called Test. His character will then appear in this cool looking scene and we can move left or right. Now let's make a build of our game by pressing Ctrl B or Command B if we're on a Mac. We'll first of all connect to the Photon server, and this time we'll join the room called Test. And you'll see that this player also appears in our game. When the two characters get near enough to each other, this chat UI appears on both player screens. Of course, the chat doesn't work at the moment, and that brings us to the topic of this video. So let's begin. Before we get started, I just want to let you know that you can download the project, link will be in the description. So we can code out our own chat system, but that will take a huge amount of time, and it's pretty complex. That's why in this video, we're going to be using a service called Stream that you can have access to for free, that lets us very easily create amazing chat systems in a fraction of the time that it will usually take. In this tutorial, we're really going to cover the first steps to making a basic chat system with only the possibility to send and receive messages. But Stream lets you basically create any chat you've ever seen in any game. You can add reactions, have different user roles, add attachments, and much more. So step 2 is to download Stream into our project. So head over to this link. So it's getstream.io/chats. Now let's come over to the SDKs and let's choose Unity. We can then click on this download code button that will bring us to the GitHub repository. Now let's simply click on this green code button and then choose download zip. This will just take a couple of seconds, and once it has been downloaded, you'll need to extract the zip file somewhere on your machine. Okay, once you're done, open Unity, as well as your file explorer, and then simply find the folder that you just extracted from the zip files, double click on it, then go inside of the assets folder, and now we'll just drag and drop the plugin folder directly inside of my Unity project. Great, the SDK has correctly been imported in our projects. We now have all the tools and code that we need to create amazing chat systems. Now we also need to create a Stream account. So Stream is not usually a free service, even though they do propose a 30-day free trial, but don't panic. What's really awesome is that they propose a free maker account. This means that for us indie game developers, we can have access to Stream completely for free. So click on the first link in the description that will bring you straight to this page. So then just fill in all the info and apply for the maker accounts, and you'll be good to go. Alright, so once you have your account up and running, let's click on this dashboard button. Here you'll have a list of all the apps or games that you have created chat systems for. So let's click on this create app button. For the feed server location and the data storage location, just choose where you think most of your players will be based in, but it's really not that important. I'll choose EU for both. We don't want to clone any app, so let's leave this blank, and we will choose development for the environments. Let's now click on the create app button. You'll now have access to all the settings of your app. The only one that we're going to change is this authentication that we're going to disable. In this demo, we're going to bypass authentication for simplicity, but in real production, we need to set up a simple server-side logic using the Stream server-side SDK, and we generate user tokens on our own. Okay, step 2 is now complete. Let's move on to step 3, which is to create or log in our chat users that will be sending and receiving messages when we click on this connect button. So in this connect scene, we've just got this input field so we can type the name of the player and a connect button. I'm going to create a new empty game object that I'll call Stream Chat Behavior. Now let's come to our scripts folder, and I'm going to create a brand new C# script also called Stream Chat Behavior. Once it has been created, drag and drop it onto our newly created game object. Now we can double click on it to open it up inside of Visual Studios. First of all, we're going to need to use all these namespaces inside of the script. Okay, next thing that we'll need to do is to make a singleton out of the script, because quite a few scripts are going to need to access this script, so making a singleton will make that process nice and easy. So I'll make a public static stream chat behavior variable called instance. Then inside of the awake function, we will set instance to be equal to this. So we're just setting the instance variable to be equal to this script. So thanks to the static variable, we will not need to use stuff like find object of type to get access to the script. We will simply need to say streamchatBehavior.instance and we'll be good to go. Alright, we're also going to want this script to not get destroyed when we change scenes. So to do that, we'll just type this line of code inside of the awake function. Don't destroy and load this. Okay, so remember, step 3 is to create or log in or stream users. So I'm going to create a variable of type iStreamChatClient that I'll simply call clients. This variable will store our clients, so our chat user with all its info. Now let's make a public void function called get or create client. They'll take in as a parameter a string called username. The first thing that we need to do is to sanitize the username that we'll be passing in. Sanitizing basically means that we'll remove from the username any unwanted characters such as commas, exclamation marks, and so on. So I'll make a string variable called userID that will set it equal to streamChatClient.sanitizeUserID and we'll pass in our username param. Next off, we need to create our user credentials so we can let Stream know what chat user we're trying to create or log in. So I'll make a variable of type auth credentials called credentials, and it will be equal to a new auth credentials. Now inside auth parentheses, we need to pass 3 different values. The first one is the API key. To find this, just head over back to our Stream dashboards, and inside of the settings for the app that we made, you'll find the API key. Just copy it and paste it in here. This will let Stream know that we want to create or log in a user that is on this specific app. The second param that we need to pass is the user ID, basically his name. So we will of course use our user ID variable that we made just on top. The final param that we will pass is the user token. Now, like I mentioned before, for a real production game, you would need to generate these tokens on a server-side script. But for the purpose of this video and for development, we could just type streamchatClient.createDeveloperAuthTokens. We'll pass in as a parameter our user ID variable. This function will generate a authentication token for our user. Note that you can only use this function if you disable the authentication checks in the app settings, which we did before. If you're wondering what a token is, it's basically like a password. We use them to log in users to their chat accounts. Tokens are just safer than passwords. Now that we have passed in all the credentials, we're going to set our client variable to be equal to streamChatClient.createDefaultClient, and we'll pass in as a parameter our credentials variable. So this line will actually go ahead and create a streamChatClient with the credentials that we passed in. If the user ID already exists, it will just retrieve that user. Then underneath this line, we will type clients.connect so that we actually log in our clients. Now that our client has been connected, we can subscribe events to our clients. This just means that our clients will call different functions when certain events happen, like receiving messages and so on. But for now, we'll take care of the event connected that gets triggered when our client successfully connects. So I'll say clients.connected plus equals onClientConnected. Here we're subscribing to this event. This just means that when the connected event gets triggered, we'll automatically call the onClientConnected function. This function of course doesn't exist yet, so let's go ahead and make a void function called onClientConnected, and we'll just debug.log streamClientConnected. Inside of the update function, we need to update our client so that he can get notified when different events happen. So in my update function, I'll first of all check if our client is not equal to null. If he isn't, then we'll call the client.update function, and inside of the parentheses, we need to pass time.deltaTime. Okay, we're all done in the script for the moment, so let's save it. We now need to call our get or create client function somewhere. So I'm going to go ahead and open up my connect to server script. This script is attached to a game object in the connect scene and is in charge of connecting us to the Photon server when we click on the connect button. Now inside of the onConnected2Master callback function, which is a function that gets automatically called by Photon when we successfully connect to the Photon server, we'll say streamChatBehavior.instance.get or create clients, and we will pass in as a parameter our name input field.text. Indeed, we want to create or log in to a user with the user ID being whatever we typed inside of the input fields. Alright, let's save the script and go back to Unity to test it out. So pressing play, I'll type Liam inside of the input fields, then I'll press on the connect button. After a couple of seconds, we'll get transitioned to our lobby scene, and if you have a look at the console, you'll see that we get our message saying that our stream client has been connected. Great job. Now let's quickly go back to our stream dashboard, and inside of the app settings, I'll click on this Explorer button. Now, if you go ahead and click on users, you'll be able to see all the users that are registered on this app. So if everything worked, you should see that the user that you just made appear here. As you can see, with this button, we can also manually create users from the dashboards and assign them different roles. These roles dictate what actions the user can do, and you even could create custom roles. By default, users that we make from within our script have the default user role. And with that, step 3 is complete. Let's now tackle step 4, which is to create and or join channels and start watching them when we create or join a Photon room. So a channel is basically a specific chat, a specific instance of a chat. And each time that we create a room with a different name, we're going to want to create a channel with that name. When we join the room, we'll just want to join the channel that has the room name that we are joining. So let's go back to our streamChatBehavior C# scripts. I'm going to make a public void function called get or create channel, and it will take in as a parameter a string for the room name. Now Stream uses the await async workflow instead of the coroutine workflow. So both of these workflows let us call functions that can pause execution and return control to Unity, but then continue where it left off on the following frame. The async workflow has a few really cool perks, like being able to return values from the function, which is not possible in a coroutine. So inside of my function, I'll call another function named get or create channel async. And we'll pass in the room name param. We'll also add .log if fields. Async functions don't return any error messages, so we're adding this function so that it logs an error message if a problem occurred in this async function. Let's now actually create this async function. So to make an async function, I'll type the keyword async, then we need to specify the type that we want to return from this function. Now, we don't need to return anything from this function, so we would normally just put voids. But because we're going to need to retrieve a value returned from another async function, we'll need to return a task. Lastly, let's finish with the name of the function, so in my case, that's get or create channel async. That will take in as a parameter a string for the room name. Now inside of this function, I'll create a channel get or create request called request. That'll be equal to a new channel get or create request. Inside of this object, we'll set state to be equal to true and watch to be equal to true. So this line is basically going to generate a query that will let Stream know that we want to get or create a channel, and we will want to get info about the state of the channel as well as watch it. In other words, get events from it, like message received and so on. Now let's actually use our request and create or join a channel. But before that, we're going to come to the top of our script and create a channel state variable called channel states. Just like the client variable we made stores our stream user, this channel state variable will store the channel that our user will be in. Now back to our async function, I'll set channel states to be equal to await clients.channelAPI.get or create channel async. So the await keyword here lets us retrieve the return value from the function so we can store it in our channel state variable. Now this function needs 3 parameters. The first one is the type of channel that we want to make. So usually we would use a messaging channel. The problem with messaging channels is that users that are not members of the channel cannot read the messages. We need to have backend code that adds users as channel members. But in this tutorial, we are only focusing on the Unity part without the server-side code. So that's why we'll be using the livestream channel type that treats channels basically as public rooms for anyone to read. So yeah, different channel types have different permissions. Okay, now that we've chosen our channel type, we need to set our channel ID or name. So I'll pass in our room name parameter. The third and last param that we'll add is our request variable. Let's now save the script and head over to the create or join room scripts. inside of the onJoinedRoom function that gets called automatically by Photon when we join a room, I'll call the streamChatBehavior.instance.getOrCreateChannel function, and we'll pass in as a parameter PhotonNetwork.currentRoom.name. And that's all we need to do in order to create and or join channels. So let's play our game. I'll connect as Liam, and I'm going to create a new room, which will also create a new channel that I'll call Test1. Once we create the room, our character spawns in our game scene. Now let's head over back to our Stream Dashboard App Explorer, and underneath the channel dropdown, you should see the channel Test1. Okay, we're making great progress. Let's now move on to step 5, which is to send messages. So I'm going to jump back inside of my Stream Chat Behavior scripts. Let's create a public void function called sendChat. They'll take in as a parameter a string called message. Like before, inside of this function, we'll just call a async function named sendChatAsync, and we'll pass in 3 different parameters. The first one is the message that we want to send, so I'll pass the message param. The second is the channel type that we are sending the message on, so I'll use our channel states.channel.type. And the third and last param is the channel ID, so I'll say channel states.channel.id. And like before, we'll add .log if field so that we can capture any errors in the async function if something goes wrong. This now creates the async task sendChatAsync that takes in as a parameter a string for the message, a string for the channel type, and a string for the channel ID. In this function, I'll make a send message request variable called request that will be equal to a new send message request. Inside of this object, we'll set message to be equal to another object of type message request, and we'll set the text value to be equal to our message param. Now that we have this request, let's actually send a message. So I'll say await client.messageAPI.sendMessageAsync, and we will pass in respectively the channel type param, the channel ID param, and finally our request variable. Alright, and with that done, we can now actually send messages on our channels. Back to Unity, let's open up our game scene. I'm going to create a brand new empty game object called sendMessage. Once it's been created, I'll create and add a new C# script to this object, also called sendMessage. Once it's been created, double click on it to open it up inside of Visual Studios. First of all, I'll import the TMP Pro namespace. Then let's create a public TMP input field variable called messageFields. Like the name suggests, this variable will store our input fields where we'll be typing our messages. Now let's create a public void function called onClickSendButton. This is the function that will get called from our onClick event on our send button. Inside of this function, we'll simply call our streamChatBehavior.instance.sendChat function. We'll pass in as a param our message field.text. Alright, let's save the script and go back to Unity. I'll now open up my UI and find the send button. I'll come down here and click on this plus sign to add a onClick event. Then we'll drag and drop the send message object in the slots, and then we can find our send message script and search for the onClick send button function. Alright, pressing play, you'll now be able to send messages on our channel. However, we don't see those messages pop up in our game. So that brings us to step 6, which is the final step in this tutorial, and that is to manage receiving messages and to actually show the messages in Unity. Okay, so back inside of our Stream Chat Behavior script, we're going to come back up to our create client function. Underneath the line where we are subscribing to the connected events, we will subscribe to the message received events. So I'll type clients.messageReceived plus equals onMessageReceived. So our onMessageReceived function will automatically get called when the channel that our client is watching receives a new message. There are lots of different events that we can handle, like message updated, message deleted, reaction received, and so on. So if you want to do something when those events happen, this will be the place to subscribe to those events. Alright, let's now create our void onMessageReceived function that takes in as a parameter a event message new called newMessage. This param will automatically be equal to the new message that we received. Let's quickly go back to Unity for a moment. So inside of my resources folder, I've got this message prefab that looks like this. So it's just this sort of box with a text for the message and a text for the username that sent the message. This prefab also has a completely empty C# script on it called message. Now we're going to want to instantiate these messages objects inside of this content object on our scroll rect UI elements. This content object has a horizontal layout group component so that the messages get correctly displayed one after the other. The content object also has a content tag on it, so we'll be able to fetch it from within our script. Alright, back in our script, I'm going to create a public message variable called message prefab. We'll also make a transform variable called contents. Now let's make a public function called setContentObjects. And this function will simply set our content object to be equal to GameObject.findGameObject with tag content.transform to get the transform component of that object. Now let's quickly go back to the send message script. And inside of the awake function, I'll call the streamChatBehavior.instance.setContentObject function. We're doing this because we only have a content object once we reach our game scene, so that's why we need to call this function. Okay, back to the other scripts and back to the onMessageReceived. I'll simply instantiate our message prefab, and the second param will be the parent object, so I'll put the content variable. Alright, great. Now once we instantiate the message prefab, we need to change the message text as well as the username text to the correct values. So I'm going to open up the message script that is attached to our message prefab objects. In the script, simply create two variables, a public TMP text variable for the message text, and another public TMP text variable for the username text. Don't forget to import the TMP_pro namespace. Okay, once we've done that, we can save and close the script. Back to our streamChatBehavior script, we'll store this newly created message in a message variable called newMessageSpawned. Then underneath, we'll set newMessageSpawned.messageText to be equal to our new message param.message.text. And then we'll set newMessageSpawned.usernameText to be equal to newMessage.user.id. Alright, awesome. Receiving messages and spawning in our message prefabs should now work. But before going back to Unity, it's a good idea to also disconnect the client when the player leaves the game. So I'm going to make a public void function called disconnects. In this function, we'll first of all unsubscribe to any events that we subscribe to. So in my case, I'll say client.messageReceived minus equals onMessageReceived. Then we'll call the client.dispose function to actually disconnect our stream clients. I'll call this function inside of my player character scripts. So I'll use the public override void onDisconnected function, which is a function that gets automatically called by Photon when the player gets disconnected. And in this function, I'll simply call streamChatBehavior.instance.disconnect. Alright, perfect. Let's save the script and head over back to Unity. I'll go inside of my resources folder and I'll double click on my message prefab. This way I can now drag and drop my message text and the username text inside of the respective slots. Okay, let's test everything out. So to simulate another player, I'll build a version of my game by pressing Ctrl B or Command B if you're on a Mac. Okay, so with the Unity version, I'll connect to my game as Liam, and I'll make a room called Test2. Now on the built version of my game, I'll connect as Noah, and I'll join the room Test2. Now when both players get near enough to each other, the chat UI appears, so Noah will write a message saying hello. And perfect, it is appearing on both versions of the game. And now Liam will respond by saying yo, and again both clients receive the message. Great job guys for completing this tutorial. As you can see, using Stream makes creating chat systems really easy and fun. So I encourage you to click on the link in the description and apply for a free Maker account so you can use Stream for free in your games. If you enjoyed this video and learned something cool, then hit the like button, it means the world to us. Also comment if you have any problems or questions, we will try to respond to you as soon as possible. Thanks for watching, cheers!